All right. Today, we're going to be covering 5 different tips and tricks to actually help you improve performance in your video game. As you can see here on the screen, here are the 5 tips if you'd like to fast forward to a specific one. But in general, these tips have helped me in Starlight Brigade gain nearly a 50% increase in performance. I went from about 60 to 70 frames per second in game to almost 120. Now, it does kind of cap at 120, so it could even be higher in certain situations, but it kind of bobbles between 110 and 120. So just to be more honest with you, it's about a 50% increase. So let's go ahead and jump right in with tip number 1, which is actually going to be using our stat unit graph to actually see where our bottlenecks are. Now, this sounds kind of like a duh, but for a lot of new beginners, they don't know about these command lines. So we're going to kind of talk about those here. So if you hit your tilde key, that's the key to the left of your 1 button and above the tab button. It looks like a little squiggly line. If you go ahead and hit that, you're going to open up a command line down at the bottom, and you type in stat space unit graph. So you've got unit graph, and then here you can actually type in stat space FPS, and these will provide you a couple of different tips and tricks, different tools. To actually figure out what's going on. I prefer the unit graph because what this does is it provides you your unit graph in the bottom left for a very easy visual way to see over time what's happening. So if there's a sudden spike, even if you don't notice it in all those numbers going on the right hand side, on the left you'll see that spike visually. And so with that, as you can see here, my game currently is running at 8.3 milliseconds, and I believe the big thing is sort of a mixture of your game and your GPU. So your gaming GPU time, or draw time as well. Draw time is probably what people picture as your GPU usage. So draw time is your actual what polygons you're rendering on screen. So if you got a lot of meshes or a lot of really complex meshes, you're going to see that draw time go up. Your GPU time is the complexity of like your shaders and everything, just sort of how detailed your materials are. Very complex materials, you're going to see a really high step up in that. And then as well, you have your frame time, which is a combination of your game time, which is sort of your blueprint, how complex your blueprints are, with those other factors sort of combined together, because your frame time is your actual time between frames. So let's go ahead and also, I'm going to, to show it off, I'm going to hit stat FPS here. And so now you can see that we're basically almost locked at 120 FPS right here. And that's with 4 AI enemies who are tracking in on me and everything kind of going on in the background. The only thing I'm not doing yet is I'm firing my engines, which does eat a little bit into that, but still we're basically locked at 120. That's what I meant earlier about the whole, like, it could be even higher. So let's go ahead and, so now we kind of covered this. Let's cover some of the different view modes while you're using stat unit graph. Some handy view modes is if you notice that your draw time's really high, or maybe your GPU time's really high, you can hit some of these function keys here at the top, and those will give you some different views you can use. So F1, this gives you your sort of wireframe view. This is a really handy way to quickly glance at anything and notice if any of your meshes are a little bit too high poly or look unusually high poly for some reason. You can go ahead and do that. F2 is basically your base colors, so your diffuses but without any lighting. Or I think it's technically it's like a flat lighting. That way there's no like kind of reflections, none of that. It's just sort of like what you see at the most simple level. You got F3, this is your default view, so this is just the regular view. Yes, and then F4 is without reflections, I believe. I'm not actually sure entirely on that. F5 is actually your shader complexity. This is how complex your actual shaders are. So you can see for here, everything's green. And then you have, I believe that is most of them. You can hit F10 to save screenshots. F11, of course, to full screen or not full screen. But yeah, so that is pretty much everything when it comes to this first tip. So that's a really great way to kind of see, where you're having the biggest problems, what's sort of, your bottleneck for your game. And once you find your bottleneck, you can move on to your next tip here, which is going to be using insights. So let me actually open up this. I like to dock this in the layout. For some reason, these aren't docking. Oh, I bet it hit. Okay, yeah, there's a key up here. One of these key bindings that actually kind of throws everything for a loop. And so what I like to do is just go back to Window, and then load default editor loadout, and then yeah, there we go. Or layout, I mean, not loadout. And then just redock this. All right. So now we're going to do something called insights. Insights is really helpful for sort of getting a fine-tuned look at what's causing your performance issues. Now with that, there's a lot that goes into it, and it's still a developing tool, but they are replacing front end session with this. So this is going to be your catch-all for performance catching inside of Unreal Engine. So what you have down here in 5.2.1 and newer is sort of your buttons here. Actually, it might be in 5.2 or newer. I don't remember exactly if they added it in 5.2. I just upgraded straight to 5.2.1. But you've got your trace button here that gives you a lot of different options. But the biggest ones you want to focus on is stat named events, which you do have to turn on currently every time you load the engine. In the future, they'll probably just have that turned on by default if you check mark it or like saved it somewhere. But that is one of your most important ones. And then you have a couple options here. So there's live session on trace start. You can show and explore after trace if you want to actually see the trace file itself, or copy paste it somewhere, send it to somebody. Then you have open trace insights after trace. So this will actually open up the insights program once your trace is complete, which is pretty important if you want to do some profiling. Now you can trace a bookmark if you have a specific bookmark you want to do, or trace a screenshot. But usually what I find is the most helpful is going to be these channels. So there's a lot of channels here. You don't have to have everything. What you want to kind of focus on are the things that are going to be kind of the most important part of your actual performance profiling. So usually I'll uncheck anything that I don't think is very important, and then go back in and add additional things. So as an example, most of the defaults are pretty okay. I just usually uncheck screenshot because I'm not going to be taking any screenshots. And then I'll check mark physics, Niagara, object. If I was doing any online profiling, you may could hit net. And then maybe loading time could be handy because if you're loading a lot of assets, that's pretty important to know. These other commands, I haven't gotten enough into profiling to know exactly what to look for with these. But if you know a bit more about profiling, RHI commands or RDG, or even just render commands, definitely you can check mark these as well. So let's just say these are the channels we want. And what you want to do is you want to go ahead and you can either hit start tracing here, or you can actually just hit the button down here as well. And what they'll do is they'll start tracing, and then you can just go ahead and jump into game. And you want to play for at least a little bit to get a good, kind of idea. If there's something specific you're wanting to profile, so a specific event in game, you can go ahead and actually do that, and sort of zoom in on that specific event that you want to look at, or level you want to load. But for this, since my game's all in one single level, I'll just go ahead and hit the gas and run some particles there. In fact, we'll crank up the particle spawn rate like that. That also increases our speed, so we can have a little more fun with it. All right. So we'll kind of do some stuff here so we can kind of get some good data. And then once you've played enough that you feel like you've gathered the data you want, you just go ahead and hit escape. And then we will minimize the screen here and stop tracing. So now that we've completed that, it's actually going to load up Unreal Insights. And we'll give it a second here. It'll say, sometimes it pops up with this weird tree is empty, and that's because it's looking at the event aggregation and it's loading everything in. So this is because of the asset loading option that we selected. If you actually go back to timing insights, you'll see your screen like normal. So let's go back here and let's take a look. So one thing you want to be aware of is there will be outliers, especially like when you're first loading in. Sometimes you'll see spikes. Sometimes when you're first unloading, you'll see that looks extra low. But one thing you want to do is kind of want to, for example, here I've got this random spike, and let's see if we can figure out, what's causing the spike. Sometimes it's really easy. Sometimes it can be a little more challenging. My hope is that as they develop this tool, you'll get a little bit better information, a little bit clearer information on what exactly is going on. But as we can see here, let's see here, we got blueprint time, we got something going on here. So this is only taking up 2 milliseconds, but this is one of the things I can control with this being part of one of the blueprints that I created. So go in here and, most of these things combined don't take up a whole lot of time, but I might, if I create this loader action, I'm like, oh man, that takes up a lot of time. I can always look in here and see what exactly is taking the most time. And it looks like it happens 4 times on a tick. Um, and it's using almost a millisecond in performance. So maybe I could reduce the timer on that or increase the timer on that so it's not happening as often, that sort of thing. I also know, there's a lot of physics things going on, so I could look into, what exactly is updating. So I see here that it looks like my main character, their hull is being updated every once in a while. Unfortunately, because it's the main character, that's probably okay. Losing a little bit of performance for something like that. And I still want to look into it. Maybe there's ways I can make that more efficient, whether it is writing functions in C++ or some other option. There's things that we can do there. And I'm going to talk about that in a little bit, if y'all saw the beginning part there. But yeah, so you got a lot of different things you can look at. The big thing you want to look for is anything that stands out as something that you can truly like do stuff about. Because there's gonna be some of this that's sort of like, front end loop tick, like how much of this is actually useful in the current edition. You can't really tell what, you can see here that there's some kind of garbage collecting going on. And it might be involving my railguns, but what does that actually mean in terms of like what is this collect garbage increments actually doing? Um, and at the moment, I don't know. Like without digging into it deeper, I'm not sure. But there are a lot of times, for example, with lighting, that you can see very easily. Oh, hey, this lighting thing's taking up a lot of my performance. I should look into this. So that is pretty much it for insights. And so that kind of leads into our next thing here. So one thing you want to do is you want to check for overlapping lighting. Now that's kind of a weird, sort of tip. But let me go ahead and show you kind of what I'm talking about. Should be able to. Oh, okay, that's because all this here, right? No. But oh, there it is. Okay. So essentially what's going on here is when I was working on my game, I wanted to have lighting coming from all different directions. Now at the time, I didn't know much about the whole skylight. So what I did is I just added 6 sunlights, all casting shadows, and that costed me about 20 to 40 frames per second, depending on the situation. Now, that was an issue because 2 things. One, I had multiple light sources overlapping. Now that is worse with point lights. In fact, I think with point lights, Unreal Engine by default will actually show you an X over top of them if they are overlapping, to say like we are not going to render this out. I think there are exceptions. For example, baking static lighting. I think you're allowed to overlap by 6, but it's still very frowned upon because even with baked lighting, it can be a little bit of a performance drain. But simply by just replacing 5 stationary lights with a single skylight massively changed my performance. And the benefit that I get is with the skylight is now, before it was all a plain white light that I was getting like general illumination. Now I'm getting actually light from the planet Neptune on the station, which kind of gives it a little bit more ambience. And then as well, my ship's a little bit darker when in the shadows. Now, of course, you have to be careful and balance that correctly because you don't want it to be so dark that players can't see, which is something that I'm kind of working through and figuring out, what's a good balance of that. But overall, it's definitely a much better way to handle things, much more performant. Let's see here. So next, we're going to talk about actually using C++ to handle more complex functions. So C++ is a bit of a complicated topic, so I won't be able to cover everything about it here. But just know that there's really great tutorials out there about how to get started on C++. Once you get started, once you get your project loading, building, one thing you can do is for anything that you've already done in blueprints, the great thing is that you can actually just add C++ functions to those existing blueprints. That's one way to really help sort of balance the performance that you get from C++ with the speed of prototyping you get with blueprints, because not everything in blueprints is expensive. In fact, there are a couple of things that are borderline identical or very close at least to C++ performance, but there are some things that are much more expensive. So to kind of show an example, we have over here, this was a sort of test I did. Basically, the test was to try in 3 different ways. We have a purely C++ option, a C++ blueprint option, and then a purely blueprint option. Now, the C++ version did the best. It had under 1 millisecond response time for the most part. It was usually about a millisecond and it was completed. The blueprint and C++ combined was just a little bit worse, but not by much. It was about 2 milliseconds, sometimes 2.5. But overall, pretty close enough that it'd be functionally identical. And then the blueprint one took about 800 milliseconds. Now, this is sort of a worst case scenario for this. This is basically doing the absolute worst you can for blueprints, and that is by using for loops as well as summing a bunch of different numbers together. So it's a lot of heavy number crunching. That is really bad for blueprints. So the benefit is that we can actually then apply that sort of mindset into actually creating C++ functions. So as an example here, this is an example of a C++ function I created for my, it's for my player blueprint, but essentially what it does is it rotates material, the instance dynamic materials that my player character has on it. So for example, in here, I have these vent panels, and to rotate them, I wanted to be able to rotate them in material so it's less expensive and doesn't require timelines. Overall, it's just better performance wise because it offloads it from the CPU to the GPU. So what I've gone ahead and done is basically created a blueprint function that basically just took in some values and then it calls the C++ functions. These C++ functions I've actually created inside of here. But you can see here I've passed in a bunch of different values. And so if we go over here, so we've got this is my library that I sort of have of just different C++ functions that I can use within blueprints. So as an example here, this is that rotate mids function. And what it takes in is an array of those material instance dynamics. It takes in a float. It takes in a name, which is a scalar parameter value. It takes in a rotation minimal value and a rotation maximal value. And then with that, it basically loops over all of those mids using that for loop. And then it basically goes, if it exists, then we're going to actually take the current index, which is using the predicate. And then we're going to say, this map value, and basically does some really complex math to just sort of rotate it over time to the position that we want it to go to. And basically I have it open it or close. So basically what I do is in here, if I am opening or closing them is basically what decides which direction they go. So you have a rope min and a rope max value. The reason for this is that you're rotating from and to a place. This allows it to then, when it rotates to that place, to then hold that position. That way it's not like when you rotate to that place, it then snaps back to the original spot, which is what would normally happen if you're not using a min and max value. And so this massively also saved me performance because I had some vent systems that were running previously that were using timers to actually open up, and timers are really expensive. Now, they both are and aren't. Timers are really expensive when you are using a lot of them for a lot of offset things that are very similar but can't be the exact same timeline. So for example here, the reason why this one is like this is because I wanted to be able to rotate these mids offset. So one would rotate and then the next and then the next. So the way I can do that is with this time elapsed. So if I actually go into the event graph up here, I'd have an event timer that would start opening the vents. And so it would pass in the time elapsed. And so with multiple vents, I could then go through and say, is this greater than this time? Then rotate this one, then rotate this one, then rotate this one. That way, I could rotate them in a specific order that I wanted to. So, all right. With that, we're going to move on to our last tip here, which is tip number 5, and that is to profile frequently and often. Now, people always say don't profile too soon. I actually disagree with that. I think that, in fact, if anything, you do want to be careful. You do want to understand that when you profile early, you're seeing early results, and so not to just take them at face value. Things change over time, but to understand that when you're early on, if I had started profiling those skylights, I would have noticed much sooner that they were causing a really huge dip in my frame rate. But instead, I waited till profiling now to go, I'm seeing that I'm not getting as much FPS as I would expect. What's going on here? And I deleted all the skylights and went, wait a second, I'm getting a huge boost in performance. And Insights is showing me that I'm getting a boost in performance because these skylights are now no longer overlapping. And then it was just like it clicked. It was like, oh, that's because of this that I wasn't aware of because I'm not a lighting person. I'm a solo dev. So I was focused more on, getting it working and making it look pretty. So once I learned that, I was like, okay, well, I don't want it to be pitch black dark. What do I do? Do I make less lights? Do I, make them not cast shadows? What do I do? And that's when I saw the tip somebody had provided me in the Slackers Discord for Unreal Engine, to actually use a skylight. The skylight would actually work better. So I put that in, and I noticed, yep, I lost almost no performance, and I'm getting this huge value in the fact that it's presenting some light on the dark sides, and it's giving me light that is in the color of this actual planet, which is super, super nice. And it might be hard to tell, so I've got a small moon over there. It's also providing that light as well. That's what kind of gives it that sort of tinge on this side. Um, it's almost imperceptible, which makes sense because that's a much smaller moon than Neptune, but it is there. And so with all of that combined, that should hopefully help you to save some performance where you can in game. If you have any more questions or any other tips you'd like to provide to your fellow Unreal Engine developers, definitely leave them in comments down below. But otherwise, good luck, good hunting.